Hello class, we're going to work on exercise 2208, and in your textbook, the end of chapter 17 that has to do with reading files talks about random access files. And random access files allow us to access a specific location within a file by offering a command. So you can think about it the same as the difference between like a VHS tape and a DVD. The sequential files that we were reading in the exercises we read earlier were like a VHS tape. We had to read them sequentially, piece by piece. When we're working with a random access file, it's like a DVD where we can jump to a specific location on the DVD to watch. Now, when we use a random access file, one term that we will use is seek. Besides the fact that the random access allows us to jump to a specific location, we can also open it as read-write. So we will use the RW parameter on our access mode to specify that we want to read that file and write it. It's going to be input and output. When we use the seek command, we're basically setting up a file pointer, and our file pointer is a location within the file where we are currently waiting. So the next read we do is going to be the next piece of information in that file. In the text, they make you very aware that if you're reading a file full of integers, each one of these file pointer items is going to be 4 bytes long, because that's how long an integer is. If we're working with long data types, we're going to be looking at 8 bytes for each item in the file. If you look in Ravel at listing 17.8, you'll see a really good example of some experimenting with a random access file and moving around, changing your seek location. And after you change your seek location, then you need to either read or write to the file based on that location. So seek moves your pointer, read or write reads the file at that specific location or writes to it at that location. Now in NetBeans, I've already created exercise 22_08. If you would create that with me, I haven't done anything special. I did eliminate the package specification so that I would just be using the default package. So right now, my 2208, there it is, Java file is just the basic default, sitting there with the empty main. Now, what I want to do in this application is copy a source file, and let me copy this, and then I'll let you see it so that you can create it yourself. So, I'm going to paste that. And let me get rid of some extra stuff. So what I've pasted is a new class called test file class. So if you would add that class to your project, here are the things that we need in it. It's basically a copy of exercise 17_03, only we've turned it into a class. So I named this class test file class. I set up a final variable is an integer, and this is the number of integers that I want to print on each line. So I initialize that to 10 so that I can control the output. The only method we have is a print file method, and this was the main method from exercise 1703. So I have the integer count, the try, to set up our data input stream. Right now it's reading file exercise 17_03 ... Remember, the try is within the parentheses, the conditional try that's going to close that file for us when this program terminates, whether it terminates successfully or unsuccessfully. Then we set up an integer total and set it to 0. I went ahead and added a statement to output a print line that says print file is printing with a new line character. So it'll print a couple of new lines, just because I wanted to make sure that I was running the right class. And then our while loop, while our data input source is available. We're going to set up a temporary integer to read the next integer from that file, output it. In our output statement, I added an if statement that if our count were evenly divisible by the number we wanted on each line, we would go ahead and output a new line character. Otherwise, we'll just continue outputting each number that we read from the file. And finally, at the end, just like in the exercise 1703, we will output the count and the total. And then we had our catch for the file not found and for our IO exception. Now, because we made this a static method, we can run it without creating an instance of our class. So in exercise 2208, I'm going to go to the main method and execute that just to test it. I want to execute this print file method. Come on, NetBeans. Stop, I'll figure it out. Lots going on my computer for some reason. Alright, so it copied in, finally, the statement to run that. So I'm going to run it. And I get my message, file not found. So looks good. That's what I would expect. I'll go ahead and copy the file from exercise 1703. I'll go to my Files tab, expand, find my 17_03 ... Copy it, paste it to my new exercise, and then I'll try to run this again. And now I should see my count, my total, and my output. Not exactly perfect columns, right? Because some of our integers are different sizes. For now, that's okay. All right, so we were able to run that class again without declaring an instance of it because it was a static method, and so we could just execute it. So we're going to modify that to output this .dat file that we're supposed to create with prime numbers, because as we're coding, it's important for us to create some sort of mechanism to test. And so this way, we're going to be able to test what's going on in our program. I'm going to go back to my projects folder. Right now I'm at my 2208. That's where I want to be. So at the end of my main, I'm going to create a method. Now in this exercise, they say a few things. So before I create my method, I guess I need to create some final variables, some constants that are going to hold some information for this class. So I'm going to have our array size, and they want us to set that to 10,000. That's the only thing that we need that's going to be a final variable at this point. Now, in our main, we're going to be looping through the file and creating some different things. Before we do that, let's create the method that's actually going to load the array, and hopefully this will make sense. And if it doesn't, just stick with me and we'll try to clear it all up. So we're going to start out creating this method. It's going to be a static method, and it's going to return an integer. We're going to call it read next batch. Now, if you remember in our specifications, we're supposed to fill up this array of 10,000 prime numbers to use as divisors, and then if we continue through that whole array and have not found something that divides evenly into our number, we're going to continue looking, then we've got to read 10,000 more. So that's what we're going to be doing in this method. So we're going to accept an array of long numbers, and we're going to call that prime numbers. This is going to be our array of 10,000. Now we're also going to expect into this method our file. So we're going to name this file inout. It's going to be a random access file, just like we were talking about with the end of that chapter 17 in our textbook. Now I'm going to need to add some imports. So our read next batch method is going to expect these parameters, the inout file that we're using, and an array of long numbers. That's going to be all of the prime numbers that we are going to reload basically in this thing. So we're going to start out with a variable that's an integer, and it's going to be our size, and we're going to set that equal to 0. Within a try, we're going to try to read our file. Our file, if you remember, is called inout, and we're going to say that if the file pointer we're using is less than the length of the file, so we haven't hit the end of the file basically, and the current size, which we're going to increment as we go through this file, is less than our array size. So I'm going to fix up some parentheses here. Give a pointer less than inout.length, and size less than array size. Okay, and it's just complaining about our uncaught exception, which we'll be catching. So we've got our try set up there, and while our file pointer is less than the length of our file, meaning that we're somewhere in our file, and the size variable has not reached the size of our array, we're going to add to our array. And we're going to use our size variable, and we're going to increment that after we're done. Now in this one we're doing a read long because we are writing these out as long integers. So we're good there. Okay, so this is going to be the end of our try. And then outside of our try, I'm going to go ahead and close this. just so we're clear. So now our while has curly braces and our try has curly braces. And now we're going to put our catch. And we want to catch any sort of exception as EX. And when we catch it, we're going to do a print stack trace on it and output all sorts of helpful information. Now that's going to be the end of our catch. And after that, we're going to return the size that we reached on our array. So it may be 10,000, it may be less than that if we didn't have 10,000 numbers left in our file to read. And so here's the end of our method. Okay, so now we have everything set up to where if a file exists, we will be able to read it and load up this array that we're going to use as divisors. So that's what our read next batch method is going to do. All right, we're in pretty good shape there. Now in our main, I'm going to comment out the execution of our awesome test printer class, and we're going to start up with the variables that we need for this program. We're going to use uppercase N is how many numbers we're going to use in our execution. And I want 1,000,000. Now, we need that array of longs. We're going to go ahead and set it up using our array size variable. Now we need a square root variable. We're going to use this to control our loop so that we don't keep dividing beyond the square root of our current number. We're going to start with that equal to 1, and we're going to go into our loop. So we're going to say we're going to repeatedly find prime numbers. We're going to use a method of labeling here, which is going to label this while statement. And we're going to label this as a new number. So this is like an event that we want to be able to return to. And our while loop is going to be run as long as the number that we're currently working with is less than or equal to our n, our controlling variable. Okay, excuse me, continuing on, we have set up our variables here, and we need a little bit more information before we can go into this while loop and explain it. So we had set up an integer that is going to be our square root. We've set it equal to 1. We need another variable long, and we're going to call that number. And this is going to be the number we are testing for primeness. I'm missing that there. Now, we're going to establish this number before we go into our while loop by checking our file. We're going to use that random access file, class, and we're going to call it in-out. And this is going to be a new random access file. And it's going to be called prime numbers.dat. And we're going to open it, read, write, RW. So notice that that is within double quotes also. And it's very concerned that we haven't done a file not found exception, and we will do that. All right. So when we access our file, we're going to be able to check the length of it. So if the length of our file is equal to 0, then this is the first time we've run our program. So we're going to start testing for primeness at the beginning of the numbers. Otherwise, our file already exists, and we should read it to figure out where we want to start testing numbers again. So we're going to seek that location. Where do we want to start? We want to start at the length of our file minus 8, because we've been writing long integers out to this file, and each of them are 8 characters long, 8 bits long. So we're going to subtract 8 from the length of our file to get that last file location. Then we're going to read it. We established the spot, and now we're going to read that. And that's all we need to do. In our main, let's just go ahead and add throws exception and see if that'll take care of all our exception requirements, and it looks like it does, so that's good. Okay, so this is our beginning setup, and we're establishing our n. So I'm going to put another comment there, or I mean our number. Establish our number. Are we starting fresh, or do we have a file? Okay, so we're going to continue on, and after our else clause, we are going to be ready to start this loop and repeatedly find prime numbers. Again, we're using a naming mechanism where we're naming this location, and we've set up our while loop so that our number that we established in our previous clause, as long as it's less than the number of primes we wish to find, we're going to continue in our while loop. So we're going to check to see if number is prime. I'll say number plus plus. Because remember, we're starting our loop either with the number 1 or with the last prime that we found. So in either case, those are numbers that we already know are prime. So we want to move on 1 before we begin. So this will put us at the number 2, or moving on from the last prime number that we found. Now we're going to use our file, and we're going to seek the beginning of our file. And we're going to do an if statement, and we'll come back to this in a minute. But we're going to take that square root that we established earlier, and remember it's initialized to 1. And if we're going to check to see if we multiply it by itself, if it is less than our number. And if it is, we're going to increment the square root. Remember, we're going to be using that to stop this loop at some point. And so the first time through, when our number is 2 and our square root is 1, this will be true, and so we will be upping our square root number to 2. So now within our while, we're going to establish another while, and in this case, we're going to say while I can get a file, while that pointer location is less than my file length, just like we did earlier when we were loading up our array. I'm going to add a little bit more to that while clause. Hang on. Oh, no, I'm not. It's good. We're going to establish an integer called size, and this is going to hold that size of the array. So we're going to call our readNextBatch method that we created at first, and we're going to pass it our prime numbers array and our inout file. And remember, our findNextBatch method is going to read up our file and load up the next 10,000 methods or numbers into our array, our prime numbers. So now our size variable is going to know how many actual prime numbers we have in that array. Do we have 10,000? Do we have less than that? Okay, so now if our number is prime, we're setting up an integer named k, and we're going to start it equal to 0. And we're going to execute this for loop while k is less than our size variable, meaning less than the number of entries that we have in our array. And while our array entry at location k is less than or equal to that square root we just calculated. So in this case, since our number is 2 and our square root number is 2, we're going to stop this loop pretty quick, right? To determine that 2 is prime. That's what we want. We don't want to loop through a whole bunch of stuff if we're working with a low number, even if we just, have started. Okay, so anyways, we've started out with k equal to 0, while k is less than our size, and our prime number of k is less than our square root. We're going to go through our loop, and we're going to increment k. So, prime numbers. In our for loop, if this number we're looking at is evenly divisible by the prime number in our array at the current location, then we know it's not prime. And this is where we're going to use that location we established earlier. We're going to tell Java to continue this at the next statement where we labeled it new number. So we're branching and moving our location of execution up to that new number. So again, we did this if we know this number is not prime. So we're ready to just jump out of here and skip on to the next number and start checking it. Okay. Now, if we don't exit the loop and we continue on and we go past this if statement and through our for statement and out of our while loop, then we have found a new prime number. So we're going to say inout.seek, the end of the file, and write that long. And its number that we want to write to the file. Now, that should be the end of our labeled while. So again, that's the code that we're going to skip if we hit the statement that says continue at new number, because it's going to jump up here to the beginning of our while and increment our number and start checking the next one. So as we execute this program, we should be ready now. We're going to be creating this file, prime numbers .dat. Now I'm going to scroll all the way over here to the left, move everything over, and let you kind of take a look at this before we run it. We have one class level variable, our array size, in our main. We set up a final long n to hold how many numbers we want to print. We set up a prime number array of long variables. We set up an integer named square root that we're going to use to control our loop, and a long named number, and this is the number we're going to be testing to see if it's prime. We establish our file, establish our starting point with our number variable. If we have no file, our number is going to be set to 1. Then we go into this while loop that's been labeled as location new number. The first thing we do in our while loop is increment number that we're going to be testing. We seek the beginning of our file. That's so that it's in the right location when we call our method to load the array. We check to see if we need to up our square root. And then we go into our while loop. And in our while loop, again, we're going to run that method that loads our array. We're going to check the number we have against all of the numbers in the array. And if it's prime, we're going to write it out. If not, we're going to jump up and test another number. And here's our read next batch method. In our try, we open the file that's been passed to us and we read it into our array, and then we return the size of the array to our caller so that they know how many prime numbers have been loaded up in the array. I'm going to try to run this, and I'm just going to let it run for a little while, like, I don't know. Now, as it's running, we are doing a lot. Remember, as we're going through all of these different prime numbers. So I'm going to look at my Files tab, and sure enough, I do have a prime numbers.dat file that's been created. So my program is doing something that I would expect. I'm going to stop it. And I'm going to delete this file so that it will start over like it's the first time. And in my prime numbers, in my main, at this if statement, I'm going to set a breakpoint, and I'm going to debug my program because I want to see this executing. So I'm going to step into it, and here I am, and I'm going to keep stepping. Rearrange things a little bit so that you can see them a little better. Now here's my N, our limit for how long we want our array to be. There it is. So I'm going to keep stepping into. Now this is going to set up my square root variable. Do you see it now? There it is, set to 1. Now I'm going to go into the code that's going to check to see if this file exists or not. So I'm going to step into, and it's going to be really messy because it's going to show me all of the Java code. So I'm going to try to step over. There we go. And get back to our code. And now we see that we're continuing on here. Let's go. Now, we're checking to see the length of our file. We have to do some of that system Java code, and sometimes it can be quite lengthy, and we can jump over it. So as we go, our prime numbers array right now has not got anything in it, and our in-out shows us the file that we're working with. So I'm going to continue to step into, and I see that it executed the code to set my number equal to 1, and now it's going into the while loop. It's going to increment number. It's going to look for the first location in the file. Again, I'm going to have to kind of do some stepping over to get past all of the Java system code. And then I'm back to my code, and I see my check on square root. And we'll continue on stepping into that to see that it's going to increment square root to be 2, which is what our number is now. So we should be writing this one out to our file. So let's see if we can tell that that happens. We're in our while statement, and here we're writing that number out to the file. And again, there might be a lot that we have to kind of skip over here of Java system code on that writing, as it's writing things internally, doing its thing before we get back to our code. So that shows us a little bit as we step through how our loop is happening. Now I'm going to continue on, and now we're back to the beginning of our while loop that's labeled. We're incrementing number. So what is number now? Let's check. Right now it's 2. After we execute this line of code, it should be 3, right? There we go. Now it's 3. So that's the number we're going to be checking for primeness. Now, are we going to read through our file to check that? Yep, so we're going to do our read next batch, and in our read next batch we're going to load up that array. Now we only have one number in the file, so it'll be pretty quick to load up that array. But as you execute through this, it'll get longer and longer and longer. So notice that each time it checks a number to see if it's prime, it reads through the entire file of prime numbers so far to load up the array. Okay, I'm going to stop this, and I'm going to stop my breakpoint. And again, I'm going to execute my program for a little while. And while it's running, I want to fix my code to print out the file. So that's my test file class. And what I need to do here in this one is make this work with long integers and my new file name. Okay, so my file name is going to be prime numbers dot dot. And our file is in the same project, so we shouldn't have to worry about that. And instead of a read int, I want to make it a read long. So I need temp to be a long. So I probably need everything to be long, right? Okay, so I have a long count. I'm going to read in prime numbers dot dot. I have a long total. I'm going to read it in as soon as I can. That should do it. Okay, so I'm going to go back to my running program and stop it. So when I stopped it, remember Java should automatically close my file for me because I had that conditional open, right? Okay, so now let's try to run this test file class. We're going to go back to exercise 1703. Sorry, 2208. And I'm going to tell it to print our file. I'm going to comment out the rest. I'm sure you can do a much more glamorous job than I at figuring out a way to do that, but I'm going to go ahead and run this. And there are all the prime numbers that have been written to my file so far when I stopped it. So it's looking pretty good. I see that I've got 235. Oh wow, it's looking great. And that's how I'll be kind of testing yours, is by using that output file print. So good luck. Let me know if you need any help. I think you've got everything now.